7.6 on linear programming. There are applications in business and economics that involve a process called optimization, where you're asked to find the minimum and maximum of a quantity. One of these strategies is called linear programming that we're going to look at in this lesson. So a two-dimensional linear programming problem consists of a linear objective function and linear inequalities called constraints. The constraints determine the set of feasible solutions. So to solve a linear programming problem, first you're going to sketch the region that corresponds to the system of constraints. So you're going to graph the system of inequalities, and whatever overlaps is the region that contains the feasible solutions. We need to find the vertices of that region and plug those vertices into the objective function. Once you've plugged all those vertices into the function, you're going to determine which one of those points will give you a maximum and which one will give you a minimum value in the objective function. Okay, so in example 1, we've already been given the objective function z equals 4x plus 3y, and the constraints are x is greater than or equal to 0, y is greater than or equal to 0, and x plus y is less than or equal to 5. The constraints have already been graphed, and where they overlap is this triangle that's shown. So after you graph the constraints, you need to identify the vertices of that area. So we have 0, 0, 5, 0, and 0, 5. Now we're going to take these numbers one at a time and plug them into the objective function and find out what the value of z is. So if I plug in 0, 0, 4 times 0 plus 3 times 0 is going to equal 0. If I plug in the ordered pair 5, 0, 4 times 5 plus 3 times 0 will give me 20. And then if I plug in 0, 5, 4 times 0 plus 3 times 5 will give me 15. So we're looking for the maximum value and the minimum value. So the maximum is when z equals 20, and that's the point 50. The minimum is when z equals 0, which is the point 0, 0. Okay, same thing on number 2. We're given a different objective function and the constraints have already been graphed. Where they overlap is this quadrilateral. So we need to identify the vertices, which will be 0, 0, 4, 0, 3, 4, and 0, 5. Now we're going to plug each of these into the objective function. So if I plug 0, 0 into the objective function, 5 times 0 plus 0.5 times 0, z will equal 0. Okay, if I plug in the next point, 4, 0, 5 times 4 plus 0.5 times 0, z will equal 20. If I plug in 3, 4, 5 times 3 plus 0.5 times 4, z will equal 17. And last, 5 times 0 plus 0.5 times 5 will give me z equals 2.5. Okay, so once we've plugged them all in, we identify a minimum and a maximum. So the minimum is at 0, 0, and z equals 0. And then the maximum is 4, 0 when z equals 20. Okay, so now in example 3, this time we need to graph the constraints first, then we will use the vertices of the feasible solutions to plug into the objective function. So x is greater than or equal to 0 is a vertical line through 0. So it's actually the same as the y-axis. So if it's greater than or equal to 0, then I would shade to the right of 0. Okay, next, y is greater than or equal to 0 is a horizontal line through 0, so that's going to be the x-axis. And since it's greater than, I would shade above. So right now, everything that's double shaded is just in quadrant 1. Okay, so then I need to graph the line 2x plus 5y is less than or equal to 10. I could get y by itself and find the y-intercept and use the slope, but when it's in this standard form, I can actually use the x and y-intercepts and it'll be a lot easier. So remember, the x-intercept is when y is 0. So if I plug in 0 for y and solve for x, x will have to equal 5. Same thing for the y-intercept. I plug in 0 for y or 0 for x and solve for y. So then y has to be 2. So then I just plot these 2 points and I can connect the dots and that will give me the line. Now since this is less than or equal to, then I would shade below. So what is triple shaded is this triangle that's in the corner of this quadrant. So then I need the vertices for the triangle, 0, 0, 5, 0, and 0, 2. Then I'm going to plug those points into the objective function. So if I plug in 0, 0, 6 times 0 plus 10 times 0, z will equal 0. If I plug in 5, 0, 6 times 5 plus 10 times 0, z will equal 30. And then if I plug in 0, 2, 6 times 0 plus 10 times 2, z will equal 20. So then you just need to identify which one is the minimum and which one is the maximum. So the minimum is at 0, 0, z equals 0, and the maximum is at 5, 0, z equals 30. Okay, we're going to do the same thing for number 4. We're going to graph our constraints, and then we will use the vertices of the feasible solutions to plug into the objective function. Okay, so I'm going to start with x is greater than or equal to 0. And again, that's going to be the y-axis. Now I'm going to wait till the very end to shade on this one. So if I was shading, I would go ahead and shade to the right of this green line. And then y is greater than or equal to 0 is the x-axis, and I would shade up. So again, quadrant 1 would be shaded right now. Then I have x is less than or equal to 10. So this is a vertical line through 10, and since it's less than or equal to, I would shade to the left. So right now what's triple shaded is between the green and the blue line and above the purple line. Okay, so now I want to graph x plus y is less than or equal to 7. So I'm going to do my x and y intercepts again. My x-intercept, if I plug in 0 for y, then I'm going to get 7 for x. For my y-intercept, if I plug in 0 for x, I'm going to get 7 for y. So then I plot those 2 points and connect the dots. Since this is less than or equal to, I would shade below. So what would wind up being quadruple shaded here is just this triangle. So the blue line actually didn't help us at all for this problem. Sometimes it will, sometimes it won't. So you just have to pay attention while you're shading. So then I identify the vertices, 0, 0, 7, 0, and 0, 7. And I'm going to plug those into the objective function. So 0, 0, negative 0 plus 2 times 0, z will equal 0. When I plug in 7, 0, negative 7 plus 2 times 0, z will equal negative 7. And then 0, 7, negative 0 plus 2 times 7 will give me 14. So this time my minimum value is at 7, 0 when z equals negative 7, and my maximum is at 0, 7 when z equals 14. Okay, now we're going to look at a word problem, and we're going to do everything that we did on the previous examples, but we're going to have to write the objective function, and we're going to have to write the constraints based on the word problem. So it says that a farmer can plant up to 8 acres of land with wheat and barley. He can earn $5,000 for every acre he plants with wheat and $3,000 for every acre he plants with barley. His use of a pesticide is limited by federal regulations to 10 gallons for his entire 8 acres. Wheat requires 2 gallons of pesticide for every acre planted, and barley requires 1 gallon per acre. What is the maximum profit he can make? So, first off, we need to identify our variables here. So, I'm going to say that X is going to equal my wheat, and Y will equal barley. Okay, then I'm going to come up with a objective function, which is actually the profit function. Because we're trying to maximize profit, whatever you're trying to maximize or minimize is your objective function. So for profit, we don't know what his profit's going to be, but he told us how much he can earn for each different type that he plants. So we're going to say that profit equals 5,000x plus 3,000y. And we don't know what the profit is. That's in the end what we're trying to find out. Okay, then it gave us a little bit more information. We know that he can plant 8 acres of land. Okay, and it tells us information about the pesticides and how much pesticides are required for each one. So I know that wheat and barley both have to be greater than or equal to 0. Okay, we have to plant something here. So those are my first two constraints. Okay, and then I'm going to use the pesticide information here. And we know that together we're going to plant 8 acres of wheat and barley. And for the pesticides, it said that wheat requires 2 gallons of pesticide and barley requires 1 gallon of pesticide for a total of 10 gallons. It has to be less than or equal to 10 gallons. Okay, and his acreage, that's why the first equation, x plus y, has to be less than or equal to 8. Okay? All right, so now that we have our equations, we're actually going to put these in the calculator. So I don't have to put the x greater than or equal to 0 and the y greater than or equal to 0 in the calculator. I just know that this is going to restrain me to the first quadrant. So I'm just going to take the orange equations and put those in the calculator only. Then I'm going to set my window so that I will only see quadrant 1. Okay, so if you go to y equals in your calculator, and in y1 I solve the first equation, and that would be negative x plus 8. And then the second equation when I solve for y, negative 2x plus 10. Now if you notice, my calculator does look a little different than yours because this is going to show up in color. But I've also have some different symbols in front of my y1 and y2. If you go in front of the y equals and you keep hitting enter a couple of times, eventually you're going to get this symbol, which is the less than shading. Okay, so if you get a triangle that's on top, that would be shading on top, which is greater than shading. Okay, so just go hit enter until you get the triangle on the bottom. Or you can not shade at all and just know what you're looking for is some type of a feasible solution, some type of a polygon that's going to show up, and that's where it would be shaded inside. Okay, so if you go set your window, we don't want our x's to be negative. So you can make your x's go from 0 to positive 10, and then you jump down to your y's and make them go from 0 to positive 10 also. Okay, so when I hit graph, this is what mine looks like. And it may take a minute for yours to show up everything. So I need to know about the vertices of this feasible solution. Same thing that we did earlier in the previous examples. So one that's important is the point that they intersect, where those two lines intersect out there. And you can get your calculator to tell you what that point is if it's hard to figure out. If you go to second calculate intersection and follow the instructions that the calculator asks you, you'll find out that that intersection is the point 2,6. Okay, then we also need to know the other points that are on this quadrilateral here. Well, we know 0, 0. This point on the bottom right-hand corner is 5, 0. And then upper left is 0, 8. Okay, so you can get those points several different ways. You can go to the table and find out what the x and y intercepts are. You can plug in and find out the x and y intercepts if you graph it by hand. Several different things you could do here. So now that I know these points, I want to plug each of these into that objective function and find out which one will maximize my profit. Okay, so when I plug in 0, 0 into my profit equation, I get 0. So that makes sense. If I don't plant any wheat or barley, I'm not going to make any profit. Okay, the next one at 5, 0. This would be 5 acres of wheat, 0 acres of barley. The profit would be 25,000. When I plug in 2, 6, 2 acres of wheat, 6 acres of barley, my profit is 28,000. And then 0, 8 would be 0 acres of wheat, 8 acres of barley. Then I have a profit of 24,000. So they asked us which combination is going to give me the most profit, what's going to maximize my profit here. So I'm just looking for the maximum value. So the maximum profit occurs when 2 acres of wheat and 6 acres of barley are planted. And my maximum profit that I would get is $28,000.